This video is presented to you by www.testprepadda.com. Dear students, in this session, I will start the discussion of motion of particle under gravity. When we deal with the motion under gravity, we take two important assumptions. Number one, resistance due to air is taken to be zero. Number two, acceleration due to gravity is assumed to be constant, and that is g is equal to 9.8 meter per second square. First of all, I will talk about free fall of the object. Now question arises, what is free fall? An object is simply dropped from height h. Consider this as the surface of earth and this point, let us say this height as h. So when the object is simply dropped from height h, this is called free fall. And this motion can be said as the example of straight line motion under constant acceleration. And we have already talked about straight line motion under constant acceleration. Here, this initial speed u will be written as 0 and the g, that is acceleration due to gravity, g in the downward direction is taken to be positive. Dear students, please note that the height h, this height h should be very small as compared to the radius of the earth, and that is 6,400 kilometer. And this is required if we want to take g as constant. Got the idea? Now, the velocity of the object when it reaches the surface of the earth can be taken as v, and the time, this time taken to cover this h height, if I take this as t, then to get this time t, I will use equation of motion S is equal to ut plus half at square. Now here S I will write as h, u is 0, so this part becomes 0 plus half. Acceleration due to gravity is taken as g and t square. So this way the time comes as 2h by g. So what can we say here? That when an object is dropped from height h, it will reach the earth in how much time? Root 2h by g. Now this velocity, this v, can be found with the equation of motion v is equal to u plus at. We are aware of this time t, root 2h by g, u is 0. So I can get this v as g into root 2h by g, and this way v comes as root 2gh. So here we have got the time taken by the object to reach the surface of the earth in this free fall. Second, when it reaches the surface of the earth, then its velocity will be written as root 2gh. Okay? Now I will talk about the another point when object is thrown up with initial velocity u from the earth. Now, when the object is thrown up with the initial velocity u from the surface of the earth, let us say it reaches the maximum height h. Let us say this height as h. The gravitational acceleration is in the downward direction, so velocity will keep on decreasing. Velocity will keep on decreasing and the object covers a maximum height h. Now to get this maximum height h, we can use equation of motion v square is equal to u square plus 2as. Here v will be 0. Finally, the velocity will become 0. And u square is the initial velocity. Here, the acceleration will be taken as a will be taken as minus g. Okay, so here I'll write minus 2g and s is h. So the maximum height h that we get here is u square upon 2g. Now if I try to find the time to reach this maximum height, then I'll use v is equal to u plus at here. V is 0, u is the initial velocity and a will be written as minus g, and this way I get the time as u by g. Okay, if I substitute the u in terms of h, then the time taken will be equal to 2h by g, root 2h by g. Now, in free fall also, we got time t to cover this h height as root 2h by g. In both the cases, the time taken is root 2h by g. So, what conclusion we can draw here? The conclusion is time t to cover h height is same whether object is going down or up. Okay. Now, when the object is thrown up like this, after reaching to maximum height, it comes down as free fall. Okay, this is the maximum height. Now we have concluded here that time of rise is equal to time of fall, and that is u by g, or better I say root 2h by g. Here if I take initial velocity as u. Now in this motion, if I try to find the velocity of the object at height h1, let us say this height h1, this h1 is less than h, and that is h as maximum height. This is the maximum height. So for this, if I use equation of motion, v square is equal to u square plus 2as. I'll write v as v1. Let us say here the speed is, or velocity better I say, v1. So I'll write v1 square is equal to u square minus 2gh1. So this way I get v1 as plus minus root u square minus 2gh1. Important point, students. Here plus minus two values are actually velocities of object at height h1 while going up, and second coming down. Height wise it is same. Okay, now if I try to find the time to reach this point, let us say this point as A, time to reach this point A, then I'll use S is equal to ut plus half at square. I'll write this S as h1, u is the initial, so I'll write ut minus half gt square, and this becomes gt square minus 2 ut and plus 2h1. This is the quadratic equation, is equal to 0. This is the quadratic equation, and the quadratic equation will have two roots. If you recall, quadratic equation ax square plus bx plus c is equal to 0. If this quadratic equation has two roots alpha and beta, then we can write alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. So here if I consider two roots as t1 and t2, then I'll write t1 plus t2 as 2u minus b by a means g. Okay, and t1 into t2, what can we write? T1 into t2 is equal to 2h1 by g, c by a. Now dear students, T1 T2 means basically here we are finding the time to reach point A. So actually T1 T2 means there are two times you are reaching point A, one while going up and second while coming down this way. Got the idea? That is why we have two roots here, T1 and T2. So with the help of these two, you can get T1 and T2. Got the idea? So dear students, what are the important conclusions here? What important conclusions we can draw from this discussion? Number one, time of rise is equal to time of fall. Consider this diagram. Here, time taken while going up from B to A will be same as time taken in coming down from A to B. Second important conclusion, maximum height in the upward motion when the Object is thrown with initial velocity u. In the upward motion, the maximum height h is equal to u square upon 2g. Third important conclusion, time to cover h height. Time to cover h height in free fall or time to reach maximum height in upward direction is equal to root 2h by g. Now fourth important conclusion, very important. If you drop two different objects from the same height, for example, you take cat and a rat. Obviously, the mass of cat is more than the mass of a rat. Even if they have different masses, they will reach the surface of Earth in equal time. Because here the time t, that is root 2h by g, is independent of mass. Got the idea? Now, in the next video lecture, I'll talk about few questions based upon the concepts which we discussed in this session. Thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.